Okay, on this second equation, notice that this one is not separable. There's no way to get this y out of this function. To determine if it's exact, I'm going to want to bring this dy term over to the left side so that I get x squared plus 2y over x dx minus 3 minus natural log x squared dy equals 0. So in this case, my m is x squared plus 2y over x, and my n is negative 3 minus natural log of x squared. To determine if this is exact, we're going to look for the partial derivative of m with respect to y, and we're going to look for the partial derivative of n with respect to x, and determine if they're equal. So my derivative of m with respect to y, this x squared term will drop out. And this second term, that 2 over x would be my coefficient. And I get 2 over x times the derivative of y, which is 1. On my partial derivative of n with respect to x, this negative 3 is a constant. The derivative of a constant is 0. This negative times a negative gives you a positive. And the derivative of natural log of x squared would be 1 over x squared times the derivative of the argument times the derivative of x squared, which is 2x. Here you can cancel out an x to show that you get 2 over x in both cases. So this is exact. Okay, when I determine my solution is going to be f of xy is equal to 0. And I can start by integrating this function with respect to x, or integrating this function with respect to y. Because I don't have any y terms here, let me start. This will probably be the easier method. I'm going to integrate, let me bring that natural log first, because this minus and negative will make that a positive. Natural log of x squared minus 3, integrate with respect to y. And both of these are constants, so when you integrate with respect to y, you're just putting a y on. I'll just consider this as one constant. Natural log x squared minus 3 times y plus my function, and this time my my constant is going to be possibly a function of x. Okay, and then to find the partial derivative of f with respect to x, then should be equal to m. And partial derivative of f with respect to x, here you want to take your derivative, and when I take the derivative of this inside the parenthesis, I'm going to get derivative of natural log of x squared, we did up here, gives you 2x over x squared, which reduces to give you 2 over x, minus the derivative of 3 with respect to x is 0. This gets multiplied by y, plus the derivative of g, plus g of x. And that should be equal to m, which is x squared plus 2y over x. Now, here, any constant has to be a function of x. So any terms that don't contain x should cancel out. And notice that the y term does cancel on both sides. This 2 over x times y is the same as 2y over x. Those would cancel from both sides of the equation to give you g prime of x, this derivative of x, should be a g prime of x, is equal to x squared. And to solve for g, you want to integrate with respect to x. When you integrate with respect to x, we'll increase the exponent by 1, divide by the new exponent, and then add our constant on. That's our g of x. And so our solution to the equation is going to be f of xy is equal to, here we have the natural log of x squared minus 3 times y plus g of x, which is x to the third, over 3 plus c is equal to 0. Whoa. And there's our solution. Now, if you want to rewrite the solution in a different form, you may want to solve for y. And to solve for y, you would bring these x terms over to the other side. That'll give you a negative x to the third over 3 plus minus c on the right side. And then divide by this coefficient of y. I think before... Yeah, let me just do that. So I'm going to get 3 natural log x squared minus 3, should be in brackets. That's multiplied by that 3. And if I write this c as 3 over 3, then I could combine these together so that I get minus 3c up here also. This may be a better answer because you've got it solved for y.